Assalamu alaikum guys. I am Dr. Sarfaraz Ali for the subject Introduction to Riemannian Geometry, whose course code is Math 4129. It's 3 credit arc subject. This subject is taught in 8th semester. I am from University of Education Faisalabad campus. Our today's topic is metric tensor. The quantities Gij are the components of covariant tensor of rank 2 called metric tensor or fundamental tensor. According to law of transformation of tensors, as in Cartesian tensor, Gij is equal to G P bar Q bar, and there are AIP, AJQ. AIP and AJQ are direction cosines mean these are the cos between it is actually angle cos of I coordinate and P coordinate, and similarly JQ bar mean it is cos of the between J coordinate and Q bar coordinate, mean we are dealing with two coordinate systems, mean which are we are in term of two coordinate systems, mean simple IJK system and P bar Q bar system. And if we write its transformation, mean inverse transformation, this direction cosine can be written as G P bar Q bar is equal to partial xi or partial x P bar into partial x J bar partial x Q bar Gij. And this transformation is also can be written as delta I P bar delta I Q bar Gij. All these are equivalent forms, mean AI P bar or partial xi partial x P bar or delta I delta P bar. All these terms are equivalent, mean in first term we call it direction cosine, in second term it is direction cosine, in third term it is direction cosine, although their notation is different. Mean now tensor form of transformation equation between Cartesian and polar coordinates. Let we transform Cart plane Cartesian coordinates into polar Cartesian coordinates, polar coordinates. Mean the transformation equation between the Cartesian coordinates x, y and the polar coordinate r, theta, r. As we know that x is equal to r cos theta, y is equal to r sin theta, and its inverse form r is equal to x square plus y square, theta is equal to tangent inverse over y over x. Let we transform x and y into x1, x2, and r theta we transform into x1 bar, x2 bar. This x1, x2 mean we want to these parameters should be written on the head of x uh, for our convenience. Then the above transformation equations become if we change these coordinates in new notations, mean we are changing xy into x1 x2 and r theta we are changing in x1 bar x2 bar. So left side x is equal to r cos theta is uh, converted into x1 is equal to x1 bar cos x2 bar, x2 is equal to x1 bar sin x2 bar, and similarly the right side as r is replaced with x1 bar, theta is replaced with x2 bar, so x1 bar is equal to x1 square plus x2 square. In actually if we interchange into these parameters in previous coordinates previous parameters, mean x1 is equal to x, x2 is equal to y, and x2 bar is equal to theta is equal to tangent inverse x2 over x1. And if we write in previous coordinates, then x2 is equal to y and x1 is equal to x. Okay, now if we change the coordinates, Cartesian coordinates into spherical polar coordinates, as in previous lecture we have taught, x is equal to r sine theta cos phi, y is equal to r sine theta sine phi, z is equal to r cos theta k, and its inverse form is equal to r is equal to x square plus y square plus z square square root theta is equal to tangent inverse x square plus y square root z, and phi is equal to tangent inverse y over x. Let we transform these x, y, z into x1, x2, x3, and r theta phi we replace with x1 bar, x2 bar, x3 bar. Then the transformation equation takes the form. Mean I am talking about the left side where we have x is equal to r sine theta cos phi. Our term x is replaced with x1, r is replaced with x1 bar, sine theta is replaced with x2 bar, cos phi is replaced with x3 bar. Similarly, in second term, y is equal to r sine theta sine phi is replaced with x2 is equal to in place of r we write x1 bar sine x2 bar sine x3 bar. Mean x1 bar is in place of r, x2 bar is in place of theta, and x3 bar is in place of phi. And for third equation, z is equal to r cos theta is replaced with x3 is equal to x1 bar cos x2 bar. And in inverse form, when we write r is equal to x square, y square, z square whole square root, we shift r is equal to x1 bar is equal to x1 square plus x2 square plus x3 square whole square root, and second term which is given as theta is equal to tangent inverse x square plus y square square root over z. So the second term is become x2 bar is equal to tangent inverse x1 square plus x2 square whole square root over x3. For third term which is given as phi is equal to tangent inverse y over x, we have phi is replaced with x3 bar is equal to right side is tangent inverse y over x is replaced with x2 over x1. Now we change the Cartesian coordinates into cylindrical coordinates. As you know, guys, r theta z are the cylindrical coordinates, and when we write them in parametric form, x is equal to r cos theta, y is equal to r sin theta, and z is equal to z. Mean third coordinate is equal to in both parameters, both coordinate system is equal, and r is equal to in inverse form r is equal to x square plus y square square root theta is equal to tangent inverse y over x, and last term z is equal to z. Let x y z is equal to x1 square x1 x2 x3, and r theta z is replaced with x1 bar x2 bar x3 bar. Then the above transformation equation will be in the form of x1 is equal to x1 bar cos x2 bar, x2 is equal to x1 bar sin x3 bar, x3 is equal to x3 bar. And in inverse form, x1 bar is equal to x1 square plus x2 square whole square roots, x2 bar is equal to tangent inverse x1, x2 over x1, and x3 bar is equal to x3. Now we transform Cartesian plane metric into polar plane metric. In previous two slides, we just changed the coordinates. In this slide and in further, we replace these coordinates. We transform metric tensor into plane metric in polar plane. Mean in Cartesian coordinate system we have the line element ds square is equal to dx square plus dy square, where x is equal to r cos theta, y is equal to r sin theta, and inverse form as we write in previous slides, r is equal to x square plus y square square root theta is equal to tangent inverse y over x. Let we shift x and y into x1, x2, and r theta is equal to x1 bar, x2 bar. Then the equation left side equation mean x is equal to r cos theta is replaced as x1 is equal to x1 bar cos x2 bar, and x2 is equal to x1 bar sin x2 bar. The transformation equation will be g a bar b bar is equal to delta a bar delta b bar g a b, where g a cap b cap is equal to in matrix form g11 1 1 cap g12 cap g21 cap bar g22 bar. As we know that from affine connection, delta a bar is equal to partial x a bar, and delta b bar is equal to partial x b or partial x b bar. Also, delta a bar is equal to delta 1 a bar delta 2 a bar. We just give the variation to the contravariant index a. Variation is 2 as we have only two variables. So variation to covariant index a bar is equal to delta 1 1 bar delta 1 2 bar delta 2 1 bar delta 2 2 bar. Similarly, the term delta b bar is equal to delta 1 a bar, or second term is delta 2 a bar is equal to delta 1 1 bar delta 1 2 bar delta 2 1 bar delta 2 2 bar. Here delta a bar delta 2 b bar is known as affine connections, or these are chronicle deltas. Here we write them in term of derivative. Now, as delta a bar is equal to partial x a or partial x a bar, mean when we change one variation of a is 1 and 2, and a bar variation is 1 and 2 bar. So first term become 1 delta 1 1 bar is equal to partial x1 or partial x1 bar is equal to partial x1 bar into x1 is equal to x1 bar cos x2 bar, and taking derivative with respect to x1 bar, so derivative of x1 bar is 1 and other term become constant with respect to x1 bar, so we remain with cos x2 bar. For second term, delta 1 2 bar is equal to partial x1 partial x2 bar is equal to partial x1 2 bar into term of x1 is equal to x1 bar cos x2 bar is equal to, now we are taking derivative with respect to x2 bar, so derivative of cos is minus sin x2 bar, and minus term we minus x1 bar sin x2 bar is, and now the derivative of delta 2 1 bar is equal to partial x2 or partial x1 bar, mean we are taking derivative of x2 with respect to x1 bar, where x2 is equal to partial of partial x1 bar sin x2 bar is equal to sin x2 bar, as we are taking derivative with respect to x1 bar. So derivative of x1 bar with respect to x1 is 1 and Sin x 2 bar is treated as constant, so constant remained sin x 2 bar, and derivative of our x 1 bar is 1. And similarly, the last term delta 2 2 bar is equal to partial x2, or partial x2 bar is equal to partial x2 bar, and we have x2 is equal to x1 bar sin x2 bar. Now we are taking derivative with respect to x2 bar, which is equal to partial x1 bar cos x2 bar. Derivative of sin is cos x2 bar. Now we are here, uh, we take the variation of g a bar b bar is equal to delta 1 a bar delta b b bar b delta 1 b plus delta 2 a bar delta b bar b g 2 b. We use the rule, actually here is a little bit mistake. No, it's good. We take the variation of dummy index first. Mean, as you guys look in this equation, delta a bar delta b bar g a b. So in this equation, a from delta and a from g are contracted. Same delta b and b with g are contracted. These parameters can be contracted, so these parameters are treated as dummy index, so we take the variation of dummy index first. Okay. Keeping b fixed, I consider the variation of a only. In first term I change a with 1, and in term 2 I change with 2. Now we have two terms in uh, each term. Mean, I have two terms with g1b and g2b. Now the variation of b from term 1, I change in first term b as 1 and 2 as in term 1. So I obtain two terms from first term, and from second term again I get two terms, delta 2 a bar b bar 1 g21 plus delta 2 a bar delta 2 b bar g22. Okay guys, now we in Euclidean metric, or in Cartesian metric, we have g11 12 21 22 as 1001, as we have equation dx square plus dy square. From those equations, fundamental equations, we have the matrix form 1001. So the above equation become, in previous equation in which we use the variation of a and b, g a bar b bar is equal to delta 1 a bar delta 1 b bar into value of g11 is 1, value of g12 0, g value of 210, g value of g221. I keep the values like this, and multiplying one with first term and last term, we remain with only two terms. The middle two terms are vanishes because they are multiplied with zeros. So I have in general g a bar b bar is equal to delta 1 a bar delta 1 b bar plus delta 2 a bar delta 2 b bar. Now for each term, like in the first term g11, I want to find a transformation equation, transformation metric against g11. For g11 I need g1 1 bar 1 bar. So I put a bar b bar 1 1 is equal to delta 1 1 bar delta 1 1 bar plus delta 2 1 bar delta 2 1 bar. It is interesting, these two terms become square of each other. So I have first term delta 1 1 bar square, and same delta 2 1 bar square. In delta 1 1 bar we have from derivatives cos x2 bar dot cos x2 bar, which multiplied each other and gave cos square x2 bar. Similarly, when we multiply sin x2 bar with each other, we got sin square x2 bar. And from the basic trigonometric formalism, cos square, whatever the angle is, cos square plus sin square is equal to 1 if the angle is same. So this identity becomes. Now, for second term in Euclidean metric G1 2, we need G1 bar 2 bar. So we replace in given formula G A bar B bar, we replace A bar with 1 and B bar with 2 in whole term. So we get G1 bar 2 bar is equal to delta 1 1 bar delta 1 2 bar plus delta 2 1 bar delta 2 2 bar. And substituting the values of delta 1 1 bar is equal to cos x2 bar dot delta 1 2 bar is equal to minus x1 bar sin x2 bar plus delta 2 1 bar is sin x2 bar dot delta 2 2 bar is equal to x1 cos x2 bar. Looks interesting when multiplying these two terms. So first term is the additive inverse of the second, so when we apply the additive property it becomes 0. G1 bar 2 bar becomes 0. Guys, in previous lecture I have told you mean metric tensor is metric. So if G1 bar 2 bar is 0, so the same result must be there for G2 bar 1 bar. Let's check. G2 bar 1 bar is equal to delta 1 2 bar delta 1 1 plus delta 2 2 bar delta 2 1 bar is equal to minus x1 bar sin x2 bar dot cos x2 bar plus this one, and multiplying these terms turned into 0. And the last term G22 bar is equal to delta 1 2 bar delta 1 2 bar plus delta 2 2 delta 2 2 bar is equal to delta 1 2 bar is equal to minus x1 bar sin x2 bar, and delta 1 2 bar is the square, so multiplying each other. Similarly, the right side delta 2 2 bar is the square, so we get x1 bar cos x2 bar multiplying each other. Then we got a result is equal to x1 bar square, and when we change these parameter in the previous given parameters is equal to r square. So therefore G A bar B bar is equal to, we write in matrix form, G1 bar 1 bar G1 bar 2 bar G2 bar 1 bar G2 2 bar is equal to, substituting the values of all four parameters G1 1 2 2 and others, we got 100 r square. So it's the end of the question. We take the transformation of GAB into GA bar B bar. Interestingly, in G1 GAB is equal to 1001, and GA bar B bar in polar form is 100 r square. So we move to next question.